First of all, thank you so much for joining us live today. Good morning, good afternoon, and good evening to all of you who joined us live from different parts of the world. And I hope you are keeping well and safe during this pandemic. And just know that we're all into this together, right? So I hope that we will get back to living a normal life soon. So with that spirit, let's start today's webinar series. And today's topic is productionizing machine learning and AI models at scale. My name is Tenzin Namdak, and I'm the Director of Big Data and Advanced Analytics at Sigmoid, and I'm going to be the moderator for today's webinar. We have 3 speakers lined up for today's webinar, and super excited to introduce them to you all. First, we have a guest speaker, Scott Kasper, and Scott is the Director of Data Engineering at Yum Digital and Technology. Scott's passion for using data and technology to elevate businesses and delight customers stretches several years back, beginning with his involvement in the development of the Magic Band program at Walt Disney World. In the past, Scott has also spearheaded Taco Bell's cloud journey by leading a data warehousing transformation from a decade-old legacy on-premise system to a cloud built on Amazon Web Services. So very impressive background. Welcome, Scott. We are very excited to have you here. Would you like to say hello?
Hey, yeah, thanks, Tenzin. Very happy to be here, and I look forward to speaking with you all.
Awesome. And then next we have Mayur Rustagi, the CTO and co-founder of Sigmoid. Mayur has 11 years of history of designing end-to-end architectures and building data pipelines for big data applications. He has led development of hundreds of such data pipelines in production systems for leading organizations and has put complex machine learning models into production. That's going to be one of the focus today. I have been working with Mayur for quite some time now. And one thing I really like about Mayur is customer loves talking to him because of his rich background and his very, customer-centric mentality. So welcome, Mayur. Would love to have you say hello to our audience.
Hey guys, great to be here.
Great. And then we have Rahul Singh. Rahul is the Chief Analytics Officer and co-founder at Sigmoid. Rahul is expert in building intelligent self-learning systems with over 11 years of experience in this space. If you ask me, I think Rahul has like one main goal in his mind, that is how to impact the bottom line business of the customers and increase the revenue, right? Which I believe is one of the very important characteristics of an ideal technology leader. So welcome, Rahul. Would you like to say hello? Rahul, I think you're muted.
Oh, I'm sorry. So, hi everyone. Nice to be here. Looking forward to talking to everyone.
Okay, awesome. Thank you. So, before we get started, I would like to run through some logistic details. We will have Q&A session towards the end of the webinar. I have kept about 15 minutes for Q&A, depending on how well we do with our timing, but trust me, I'll do my best. And I would like to inform all the participants that they can submit their questions to the Q&A chat window at the bottom right-hand corner side of the screen. And I'll do my best to answer all of these questions live. But if I'm unable to, I will be sure to respond to your questions offline after the webinar, okay? So here's the agenda or the topics that we will be covering for today's webinar. I'm just going to keep it as is, let us surprise you. Introductions, what does it all mean? Challenges faced in the real world, best practices and case study, all right? Let's go next. And so before we get started, I have a quick ice-breaking kind of a question for our guest speaker. When we actually started broadcasting about this particular topic of webinar, within the time frame of like 2 to 3 days, we have a very high interest from the audience. I would say like a highest registration on this particular topic, specifically when we actually ran this poll question, right? And I think we can make use of this data for the sake of today's conversation. And you can see the poll question here. The first one, at which stage of the process do your machine learning models usually suffer a roadblock? And 43% is production and integration, and the 41% is proof of concept, I think, which really makes sense to me. And the second question, sorry. In your opinion, what is the biggest challenges in operationalizing your machine learning and AI models, right? And you can see the answer here, the polling answers. So Scott, if you want to give us a quick, perspective on this, maybe you can use your Yum digital, perspective as well. That would be great to kick off this webinar.
Yeah, I think, and having had the privilege to kind of see one major use case through to production, I think there's definitely a challenge in going there. And a lot of it to me has to do with kind of the handoff from data scientists to data engineers. So I think it really, kind of falls under that category. If I look on the right-hand side of infrastructure and ongoing data quality, those tend to fall under the realm of data engineering. One of the challenges we've seen is code intercompatibility. Our data scientists like to use tools like pandas, and they like to code in Python. It doesn't necessarily translate well to a productionized environment, something you'd like to see using something like, say, a Spark or using PySpark in production. So, we've seen that. I think that really speaks to the challenges around kind of infrastructure and technology choices. I think there are machine learning lifecycle challenges. Kind of managing multiple models in production can become unwieldy. So it's important to make sure that you pick a proper machine learning lifecycle management tool, and just generally issues at scale that you don't see in test. Things like data anomalies. How well did you define your training and testing data sets? Do they mirror what you see in production? They should, but for some reasons it's not always possible for that to be the case. So I definitely excited to kind of dig into kind of some of the specifics that we've done at Yum. But the audience poll does resonate with me. So I think we probably have some folks here that have tried to do this or have researched this, because I think that feedback makes a lot of sense.
Yeah, I think I see a slide here that talks about Yum, and that probably really resonates to some of the poll responses we've got on that question, correct?
Yeah, so I can go ahead and give some background on what we've done and kind of some of our recent experiences with the Sigmoid team. But first, just kind of giving a background on my company, Yum Brands. It is the largest restaurant company in the world. So we have over 50,000 restaurants worldwide. That doesn't even include Yum China, which is another 7,200. We have 4 distinct brands, and hopefully you guys have heard of them: KFC, Taco Bell, Pizza Hut, and Habit Burger, which is a recent acquisition. We have around $5.5 billion in revenue, and then in Yum China, I think there's another $8 billion in revenue. So quite a lot of transactions happening, lots of customers, lots of restaurants, lots of data, which makes the ground ripe for exploring the topics that we're talking about today. So to that end, I kind of represent Yum Digital and Technology, which is a new division of Yum. It was formed last year with the vision to create competitive advantages and drive unit economics by elevating every customer and employee experience. And so specifically, I represent our data engineering team. And the data and analytics team, our focus is on transitioning Yum out of its traditional descriptive analytics and into the world of the predictive and prescriptive. And we do that by using data science and machine learning. we've identified over 40 use cases across our business where we could apply these techniques, including consumer, restaurant operations, and franchisor segments. And we're going to get into one of those case studies today. And so, you know, I think for a lot of you that may be newer to machine learning, you know, I think this is, for us, you know, it's a relatively new journey as well. So I'm excited to share some of the challenges that we faced along the way.
Interesting. Thank you, Scott. And what a nice, you know, detailed background on this. You know, who has not eaten KFC, right? Okay, so going to the next slide, I'll just spend about maybe, you know, 50 seconds here just to, for those who doesn't know or haven't heard about Sigmoid, just a little bit about our company. We are a Sequoia Capital funded consulting firm, and we are specialized in building large-scale data platform solutions, and with a very laser focused on data science and data engineering aspect, right? And you know, we are headquartered here in San Francisco Bay Area, a US headquarter, and other operations in New York, Dallas. We also have a small operation in Lima, which is Peru in Latin America. And total, you know, a little over 250 people spread across, you know, these different locations, serving Fortune 100 and Fortune 500 company, helping them around data and analytics problems. So that's about an intro. And without any further ado, let me introduce or invite Rahul to walk us through the age of artificial intelligence. Over to you, Rahul.
Cool. Yeah, so artificial intelligence is not a new term. It has been there for a long time. Primarily, when we look at the history of artificial intelligence, so the term was coined around 1950s, but the groundwork and this vision of having an intelligence in machine which can be artificially created has been there for a really long time, from 17th century onwards. And there has been automata and mechanical systems which were developed for that goal. Even something like regression, which is very common machine learning technique, the background of it started around 1805. So as we can see that the work and the mathematics of artificial intelligence has been happening for a long time. But the major, I think, focus on it when people actually started to look at the plausibility of artificial intelligence, it started around 1940 and 50s when Turing actually came up with the theory of computation, talked about artificial intelligence, and this term was coined at that point in time. Around 1956, the machine learning term was coined. Neural networks at that point in time was started as a mechanical and hardware system where researchers thought about just replicating the hardware of human brain and converting it to sort of an artificial system which can achieve things. And similar is the time when self-learning algorithms and other important, I think, the groundwork started in artificial intelligence. For next 1 or 2 decades, it was still aspects of new systems that were being developed, and it was more like starting point in most of the algorithms that we see today. There were multiple directions where the kind of research started. One of them was that we see today, deep learning. Its birth was happened around 1960s, and it happens as a connectionist approach, as people used to call it. Similar time, the first kind of artificial intelligence when around 1974, when there was the major first wave of artificial intelligence that came. it came with a completely different architectures around heuristic search. And at that point in time, also people believed that it's very near into the future, maybe 20 years, we will have a machine intelligence which would perform similar to an average human being. But that did not happen. And the complexity of having an artificial intelligence, even at that point in time, was I think the perception was not that correct. And finally, we came into a situation where most of the funding in this area cut down. And there was a time between 1917 and 80s when there was, it's called AI winter. And at that point in time, there was not much significant achievements or events that happened. Then we see there was another boom that started after 1980s, which came with new set of techniques around building logic and expert system with a lot of rules and technologies, which knowledge-based system that can actually uh, more like in a white box way figure out how systems work and sort of write specific rules in coding in logical systems. And that actually came up with a lot of new applications. So at any point in time, what happened was new techniques came, people got very excited, there was hype. And it solved a lot of problems, or rather a lot of good applications were achieved, but it never achieved the sort of the vision of general artificial intelligence. um, at the same time, around 1980s and 90s, we looked at CNNs and neural network revolution that started at that point in time. But again, for next a decade or so, it was not that it did not bear fruit because of certain reasons. Primarily, one of the biggest reason why in initial period artificial intelligence did not give fruit, one of the reason was computation. So computation was very costly some time back, and also memory. I think these two revolution were extremely important. Why we sort of moved into the current era. In the current era, if we see even around 1990 to 2000, we can see that IBM came up with Deep Blue, and they were able to beat chess champion Gary Kasparov at that point in time. But still, and again, there was a lot of interest and curiosity at that point in time that now this is a big event. But still, even after 20 years, more than 20 years from that point in time, but we are still not there. So then, around 2000 and 2010, what we have seen is there are a lot of new development happened. And the most important was that the computation and computing came out of uh, from the hands of very costly computation systems, which only few researchers could actually afford, to something like cloud, where anybody can actually now start to have big computation, along with big data technologies like Hadoop, Spark, Cloud was launched. And also the memory size dropped, storage size cost was dropped significantly, which allows a lot of companies to store large amount of data. And that capability gave the current boom in artificial intelligence, where researchers were able to train very deep models in neural network direction, and which is called deep learning these days. And and that is now solving a lot of challenges that were not previously solved. So from a perspective of general artificial intelligence, it is still not, I think, still a dream. But in terms of solving new challenges which were not there, and tackling new applications that can give significant value to business, so we are there. Now, in terms of looking at what is the recent future in artificial intelligence era, what we can look at is the there will be significant increase in R&D in artificial intelligence, R&D expenditure. Uh, the primarily reason is there are a lot of new capabilities have come into picture, and the deep learning revolution is still solving new challenges. So right now, the research is still bearing fruit for a lot of companies. Uh, in terms of the business applications, it's not only the research which makes the most headway, because a lot of application can be solved with the technologies which are already existed. Um, right? Sanjin, can you go back?
Okay, sorry. There you go.
Yeah, cool. So primarily, consumer AI has seen a lot of innovation with speech recognition, and NLP has gotten much better, and also computer vision has sort of solved a lot of computer vision challenges which were not earlier possible using earlier technologies. Edge computing will be a favored choice in future because of privacy reasons as well as security. So consumer wants data and computation to be at their control, and that is going to be a new sort of trend that we have seen across industries. And another, I think, important aspect is most of the businesses are looking at having artificial intelligence as an end-to-end solution, because building piecemeal aspects of it becomes very challenging. Micro verticals is another area which is, and again, looking at from the same point of end-to-end solution, as micro verticals can look at some specific solution, which is a business value solution in a particular industry. As an example, we look at predictive maintenance in manufacturing industry, which needs to have an end-to-end solution for businesses. And I think the last aspect is value of hardware. So hardware innovation is will be happening significantly in future, specifically in the area of computation and sensors.
Awesome. Okay. Let's see here.
Yeah, so we have just what we have seen is in the top industries, and there are different AI capabilities have penetration in different industries because of the primary use cases. So automotive industry, it's more towards these days the autonomous driving and cars which are coming into the picture. So the focus is more towards computer vision, robotics. In high tech and telecom, we have seen a lot of consumer conversation required. So virtual agents, natural language processing becomes a top priority. CPG, it's more about supply and demand, and the traditional machine learning forecasting. And also in product design, we have seen trend prediction becomes the new trends which are emerging in terms of the product design is very common. Manufacturing industry, it's primarily predictive maintenance, which based on sensor analytics and forecasting. Healthcare domain, it's there is a lot of wide variety of data, and primarily there is a lot of images which can help in automatic detection. I think radiology area is quite common, where vision is a primarily the main focus. Natural language processing helps in um, majorly the patient records that can be analyzed. And similarly, retail, we have seen a lot of recent development in automated retail chains, where you can have your automated transaction just pick up and walk away kind of stores. So I think that is the primary capabilities, like different capabilities and different industries are becoming more relevant. Um, these are few examples in terms of Sigmoid customers where we have worked. So Yum, I think we are going to share a case study, what we have added value in that aspect. Reckitt Benckiser, so they have invested a lot of effort in building marketing measurement, and we are seeing this trend across industries. Sales and marketing has been a primary focus for machine learning system, and that adds a lot of value to get a return on the huge investment and understanding what are the right areas to invest money. Belcorp, we built systems towards personalization, which had significant impacts on the revenue uh, from their consultant network. So we are seeing a significant value from across industry, specifically on consumer areas.
Okay, that's awesome. I wish we have enough time. I think this topic requires, maybe not, definitely more than an hour. But thank you, Rahul. I think that was a really insightful on some of the areas that you have covered today. But I just want to, again, remind the participant that they can post their questions on the, the Q&A section there. And now I would like to invite Mayur and to get his perspective on, some of the areas around what does the productionizing mean, what it should mean, and some real world, problems and beyond, and things of that nature. Over to you, Mayur.
Hi, thanks for that. So before I sort of go into the details of productionizing, I wanted to kind of set the scope correctly. So typically, if you were to do sort of a quick Google search, typically productionizing refers to, hosting a machine learning model in an API, or, in some cases, some of the more sophisticated ones may talk about how to update the model and some of the other aspects around that. But what I wanted to kind of, in our experience, what we have seen is what separates out successful projects from others is sort of the foundation and the ecosystem that surrounds this machine learning system. And today we're going to talk about the technology, process, and people implications of it, and how do you actually make projects more successful, mitigating risk. For me, a more kind of relevant way to sort of define this is how can we bring consistent business results by automated machine learning systems while minimizing risk. It's not as sexy a title, but that's kind of how I think about it from my perspective. And today we're going to go into some of those aspects here. Can you go to the next slide? So obviously, the first thing that you want to sort of capture is what is going to be the business impact. So from a machine learning model standpoint, you're building it out to actually achieve some business goal, right? So once that kind of key business goal is refined and kind of you've got understanding of that, you need all these different aspects in order to make the whole project very successful. So initially you want to have sort of a scalable environment for development, sort of accessible for data science teams to work with. And I'm going to go into some of the details in the later slides on what are the right aspects for these environments and what are the gotchas there. No, please go back. So the second aspect is primarily detailed and accessible statistics. So how do you capture statistics at different stages and transparently report them to business and the data engineering teams in order to be kind of more transparent and build trust? How do you actually then serve the system? And then finally, how do you create an experimentation framework so that the machine learning models that you build are not just kind of one-time wonders, but are actually continuing to deliver business value as the business environment changes, and you even have sort of large catastrophic events like COVID coming in. So you need to have some level of maturity in each of these areas for the projects to be successful. And depending on the type of use case and problems that you have, you may need more maturity in one area than the other. And sort of balancing this out is where sort of a lot of teams really take successful projects to production versus working with sort of unsuccessful projects. So I'm going to talk a little bit about each of these areas as we move forward. Talking about the real world problems in sort of real data that we have seen, can you just move to the next slide? I've somehow lost control of the Zoom. Okay, so today there are different aspects that we can talk about. I have focused this talk primarily talking about the risks that most companies deal with and the strategies that they take to mitigate them. There's obviously a technology side of it. What is the right technology stack? And we are going to give you some perspective on that. But this talk is not focused on the wide breadth of technology that is available in the machine learning space, primarily because the choice may vary from customer to customer and use case to use case. So I'm going to talk more about the business risk as well as the implementation risks that you see or at least that we have seen when we have put models into production, and that you might also come across in your use case. So starting off with sort of the initial setup that I talked about, which is the scalable data environment to deal with. I think then you'll have to move the slides. I'm not able to. So I start off with sort of the initial data platform challenges, and we have seen a lot of machine learning teams which start off with sort of a non-data lake approach, starting off with building machine learning models on top of their traditional databases or data warehouses. And while there doesn't seem to be from a feasibility challenge, like it doesn't perceive to be a feasibility challenge, but we have found that data science teams, you would often see spend 80% of their time in actually cleaning and managing data than actually doing productive machine learning work. And setting up the right data lake can separate out teams largely from a lot of overhead, both from bureaucratic standpoint as well as manual standpoint in a lot of these areas. So what does that mean? You basically want to have a data lake environment with easily and powerful access to a variety of data sources that they need access to. This unblocks them from actually trying out the different data sets and understanding what information lies in them in order to be more successful. They are using standard accessible systems, and that could be Parquet, standard warehouses, or any kind of standard methods to access this data and make it available easily. And the second aspect that you want to have is kind of scalable compute resources available to them and not get bottlenecked by kind of provisioning or requesting access and so on. So you want to have sort of a scalable compute environment that they can rely on in order to do ETL. Just enabling these two things, having easy access to a variety of data that they need to be productive, as well as a scalable compute environment where they can scale up and scale down to kind of ETL and process the data, analyze it, can help move them forward much, much faster in their productivity cycle. The two things that you want to invest on from a longer term perspective in this. So one is a data cataloging system. You want to have a strong cataloging system that can actually re-leverage the work that the data sciences team do. So they've cleaned up the data, they've structured in a right way, they've combined different data sources together. If they catalog it and capture it in a right way, you can have other data sciences team in the future, as well as your own systems, use that data again in a strong way if you've cataloged it and updated it correctly. Otherwise, we see a lot of teams reinvesting in creating the same data pipelines again and again, just because they've not kind of designed the process in the right way for us to be leveraging that. And the second aspect is governance and security. Depending on the size of the organization that you're working on, different people in the organization may have kind of resistance in sharing data to you because you don't have a strong governance system in place. Data is kind of very important to have siloed and covered, but it's kind of very important for us to have a strong governance system for teams to be comfortable to share data with you so that data sciences teams can actually start and access it. Again, there are a variety of technology systems to help you enable in each of these areas, but these are the things that we have found, again, kind of key things which separate out really successful teams from others. The most important risk that we are trying to mitigate here, and that's the way to kind of think about it, is we are tackling out feasibility risk. Feasibility risk primarily talks about, do you actually get data like fast enough to be actually able to do predictions on top of it? Do you have all the relevant data sets at this point to actually even do the machine learning system in place, right? So what we are trying to eliminate at this point is that, are we ready to actually even start building a model, or we don't even have the data in place to be able to start it? So that's the kind of way to think about it when you kind of move this project to be more successful now that you have access to all the relevant data sets in the next stage. Moving on. So So at this point, once the data sets are available, machine learning teams would start tweaking and start building the different models that are there in place. So once they've kind of chosen the models and are generating model weights, now it is time to kind of look at some of the other aspects of the system and try to eliminate more risks from the system. So again, the way to think about this is now we are trying to eliminate modeling risk. Is our data predictive enough for us to actually do the predictions at this point? Does it have enough information for us to actually bring about the business change that we are trying to bring about, right? And it's kind of very important to have certain constraints in mind from engineering standpoint, like Scott was elaborating. It's important to choose the right technology stack that they want to use to do production. However, it is possible for us to interoperate different modeling technologies, especially if the models that they choose are kind of compatible across multiple stacks. So you want to give them data science teams some freedom, be able to choose from a range of technology stacks or a range of modeling technologies that they can use. So you want to give them some freedom so that they can explore it in the right way, but you also don't want them to go ahead and use some technology that can really make productionizing step harder. So kind of think of it like degrees of freedom, sort of brainstorming with them and staying available to them to make sure that they are choosing the right kind of models that you can actually take to production from that standpoint. The second aspect that you're looking for is kind of how will we test this model? As they are building these models, testing of these models can be really critical because you want to make sure that these models are actually going to be integrated into operational environments. They should not throw off negative numbers or wildly wrong numbers because they're going to work on newer data every day. So again, brainstorming on how you're going to test these models is very important. You cannot ignore that fact just because testing machine learning models is difficult. The test may be statistical in nature, it may be constraint driven in nature, but you want to kind of focus on those aspects. Finally, we are good. We have eliminated modeling risk. The data is predictive in nature. We have chosen one of the modeling techs which we are okay to take to production in some form or the other. Now it's about deployment. So deployment is a lot more about a very engineering driven step, basically, because you are kind of trying to take sort of maybe not as polished code base written so far to kind of a very polished system that can be battle tested and put into production. You want to figure out how this will get integrated. A lot of these decisions may be taken earlier as well, but I know that the mechanics of it are figured out at this stage in most cases. Are we going to provide an API endpoint that people are going to fire on and get results from the model? Or is it going to be a bulk processed model that is going to be integrated into some sort of ETL tools? Depends on the use case, depends on how you're looking at it from a forward-looking standpoint. What are you going to use for workflow automation? Like, how are you going to actually orchestrate the workflow? Are you going to use sort of Cloud Scheduler in Google? Are you going to use Airflow? So how are you going to workflow automate it so that it's comfortable both for other teams to kind of integrate new things into the workflow system, as well as you get detailed access and monitoring to be able to track SLA, retriability. So a lot of those things, kind of decision making might be happening around this point in the system. What kind of coding practices you will use and where will the data scientists fit in? Are they going to be involved in the dev stack? Are they going to have full control over the system, which is something that we typically prefer, them being able to check in code and be able to see production results that are coming out of it. So sort of how do you close the loop so that data scientists can be deeply involved? And it's not a siloed activity of data scientists handing over to data engineering teams and so on. So a lot of the choices that we make around this point are all about eliminating sort of integration risk. Integrating different teams together, integrating with operational systems. More often than not, you would see a large number of sort of results that you're hoping for to start coming off at this point. You would start seeing lift in clicks if you're doing recommendation systems, conversions, and so on. Moving on, I'm going to talk a little bit about the monitoring aspects of it. As you saw in the poll above, a lot of people see that the challenges that they saw were happening when they were productionizing. And that's kind of the primary reason for that is because we have not eliminated the right risks early off in the process. The more risks we eliminate in the earlier stages, the less work is actually in this stage. Because if you look at sort of the process and structure we followed, we already checked on data feasibility, data is feasible. we already checked on modeling aspects that the models that we have chosen are productionizable, in the sense the industry has productionized them or they're supported by traditional systems. And we have also kind of eliminated the risk that the data is predictive in nature. So, we've kind of tried to outline all those things. So at this point, you're just looking to see how you can actually run the models and monitor them in detail. If you have a more sophisticated experimentation system, then you want to be able to measure the results of those experiments at this stage and kind of update the business around the different models that are running, the results that are running. And it's kind of very important at this stage to start involving more and more stakeholders to kind of make sure that the results of this model, the ROI of the system, is transparently reported, and we can actually move forward on that. In the interest of time, we'll also kind of move into the next section, which is going to talk a little bit about our real world experience with MAB here. Yeah.
Yeah. So before we just get into MAB use case, I have a quick question here, right? So I'm going to make it quick. So Scott, you you have been the key stakeholder for implementing the multi-arm bandit use case at Yum, and I know Mayur and his team has worked very closely with you. I'm a little bit curious about, like, according to you, like, what does MAB mean, right? And how important was this to the current ecosystem at Yum? And how did you go about, working with the Sigmoid team to make this a success?
Yeah, thanks, Tenzin. So MAB or MAB stands for multi-armed bandit. Which is really a reference to, a casino. You go in, you see the one-armed bandits everywhere, also known as slot machines. So the idea is, you have a limited amount of resources walking into that casino. How do you spread your money around multiple slot machines to maximize your output? Well, in our case, if you take that analogy and apply it to Pizza Hut US, where we ran this particular case study, the goal was to understand consumer behavior and how to optimize messaging to consumers with the goal of generating the maximum number of conversions for those customers. So, I think the message says it here, right? Right message, right time to the right person. And this was done over email. So why did we pick Pizza Hut US? So probably the number one reason, and this will get into something I want to talk about next, but data volume is really important. So Pizza Hut US, could you go back to the other slide for a second? Okay. So yeah, Pizza Hut US has 12 million customers and registered customers through our e-commerce channel. So we have their email address, and the typical marketing campaign looks something like what you see on the left. We come up with a marketing bundle or discount, maybe it's a special promotion that's running for a certain length of time, and we'll send that email out to our customer base and hope for the best. And obviously we're able to kind of retroactively understand which ones do well and which ones don't, and try better next time. But what if we could apply machine learning to that same use case? What if we could implement a feedback loop where we understand whether or not a campaign is successful? And by the way, going along with that multi-armed bandit concept, what if we could introduce multiple campaigns at once? So that's what we try to do with this use case. So instead of one email variant, we parameterized a number of different aspects of the email and came up with over 200 variants. So aspects like subject line, is it serious? Is it funny? Does it have the discount in it? Looking at the media that's in the email, what's the discount itself? So we parameterize all those different components. We also went ahead and segmented our audience. And the goal here is really to break down our customers in ways that make each particular message more specific to them. So,
Scott, am I the right slide? Just want to make sure.
Yeah, could you go back again for just a second?
Okay.
Yeah, so basically we came up with these 8 audience segments, and named them things based on the characteristics. So late night Larry, somebody that orders after 10 p.m. Drinks Dave, somebody who always buys their meal with a drink. And so we were able to more accurately tailor the initial variance to those customers. Now the reinforcement part of it comes into play, where we essentially measure based on number of clicks all the way through to conversion to an order during that phase of time. How far did that particular message drive that segment to either purchase or not purchase what we're offering them? And the reinforcement aspect of it was that, and this is where the machine learning comes in as well, the variants that overperform would be overweighted in the next iteration of the experiment. And the variants that underperform would be underweighted the next variant. And so over time, you're optimizing to try to encourage the messages that lead to more and more conversions. And the model's learning over time which ones those are, and it's also learning which ones they're not. So long story short of this, we ran these, what we call MAB sprints for 2 weeks at a time. And the results that I have here at the bottom reflect our 4th iteration of the MAB. So during that period of time, as compared to the control group with no MAB, we saw a 9% sales transaction lift and 8% sales lift across the business, which if you project that out over 52 weeks, would lead to $15 to $30 million in lift annually. So sounds pretty great, right? Could you go to the next slide?
Okay.
But there are challenges, as always, and some of these were stated by Mayur, in kind of a general sense, but I'll just go into kind of what we face specifically at Yum. So one is the ability to scale this use case to our other brands and other markets, right? Like, it sounds great when you talk about Pizza Hut US with 12 million customers. Problem is, we don't have 12 million customers everywhere. So, there's workarounds to that. You could kind of proxy your audience in another country, another region, and train your models that way, but it won't perfectly reflect reality. And building up a customer base is something that takes time. You can't just do it overnight. Pizza Hut's been around for years with their loyalty program, whereas Taco Bell and KFC have only more recently gotten started. So, as is typical with machine learning problems, you usually need, probably 1 million records to say you have sufficient volume to train the model. And so that can be a blocker out of the gate. And that's been a challenge for us to expand this one to other brands. Diminishing returns over time. So you run the model, you get the results. Now that becomes your control. So take the lessons learned, apply it to your baseline. Now it becomes incrementally harder to keep adding value, running it over and over again. You still want to do it because things like drift start to come into play, and you may want to understand how a specific promotion may impact the bottom line. But the costliness of maintaining and running a model, relative to the value it's adding, tends to diminish over time. Technical complexity. So kind of going to the same concept, drift and cost. If you don't properly engineer your solution, it will end up costing you quite a bit. And fortunately, with cloud and commoditized hardware and software, that's become easier than ever to do. So I think that's that's becoming easier, but it's still something that can be quite difficult to engineer, especially for a complex system like MAB, which has multiple different pipelines and different phases associated to it. Customer segmentation, offer generation, offer attribution, your feedback loop, and so on and so forth. Scalability. Kind of touched on that one already, but for a business like ours, in addition to the data being different across brands, it's a complex ecosystem. We've got different CRM systems that we need to integrate with, different points of sale that have different products, different product schemas. Your customer buying behaviors are going to be different across brands. Pizza Hut is a marketing driven business. It's based on discounts. It's assuming you're ordering pizzas for the family. Whereas Taco Bell is an individual business. People tend to go in at lunch and order tacos for themselves. So you kind of have to rethink those things every time you want to roll something out. You can't assume because it works once, it would work in a different scenario. And then the last one I want to touch on is COVID-19. Of course, has had an impact, across the world in every dimension possible. Machine learning is no exception. So, when your customer buying behaviors suddenly change, you can kind of think of that as, a drift that happens in a very concentrated span of time. Now, all of a sudden, the patterns and behaviors that we observed in the past don't necessarily apply, nor do we have the required set of data to adequately train models to the point where they were as accurate as before. Over time, that'll be the case, but hopefully things go back to normal as well. So, just want to call those out, even when you kind of cover all the, the considerations Mayur mentioned and go into production, there's always going to be challenges to consider.
Thank you, Scott. I think that was a very, insightful, background on that. Thank you. So I know in the interest of time, I actually wanted Mayur to just give us a really brief on what was Sigmoid's plan of attack on this. Mayur, do you want to spend like a minute or two on this? Can you guys hear me?
You're on mute, Mayur.
Oh, sorry, I can hear you. I'm saying just move on to the next slide. I think I'll talk a little bit about. Yeah, so I think again, in the interest of time, I'm gonna skip through some of these things, but the idea was idea of the project was not just to establish MAB, but also kind of set up the strong foundation that Yum can continue to use for multiple other projects in the future. And in the spirit of that, we broke this down into sort of technology, process, and people improvements that we need to do, and how we can actually make the thing better. So from a technology standpoint, as Scott outlined, there are multiple different businesses, some of them actually using completely different cloud environments altogether. So it was very important for us to use cloud agnostic tools to avoid sort of vendor lock-ins. This could mean open source tools, and this could also mean cloud services which can be used across different cloud environments. But we double down a lot on, for example, using Terraform to do deployments and kind of automating the whole system, and having different ways of execution of the systems, whether it is on demand or scheduled, because some models may run in one environment and some in others. From a people standpoint, we try to identify what are the different skill sets that we need across the stack. So if data scientists need to use sort of a new environment, how do we actually go about running trainings in order to train them on these new sort of tools and aspects there? From an operations standpoint, since we are using sort of new technology to do deployment and CI, how do we train from operations team in order to be more productive? So we try to identify what were the different gaps and made sure that each aspects of the team was made aware and those skill gaps were covered from that standpoint. The third aspect was, again, process. So try to follow a standardized process to take any model to production. And that way we are also testing all of these different processes and making sure their acceptance from different teams throughout the different stages, again, eliminating risk. And this also becomes sort of a playbook for any future teams to take some things into production from a machine learning standpoint, so that everybody knows what their work is as they are sort of moving forward through different stages. Moving on, this should give you a sense of the different types of folks that are involved. Again, your mileage may vary. Different teams have different compositions, but what I'm trying to highlight here is sort of the cross-functional nature of the projects. And it's very important to involve all these different cross-functional teams in the beginning of the project itself. So have a strong DevOps team, which has some understanding of how models are going to production, having a strong data engineering team that has understanding of the technology stacks, and then having a strong data sciences team to kind of be able to plan out that roadmap. Having them early in the process avoids a lot of rework and kind of allows them to kind of create these large level epics in the beginning itself, so that the teams, while doing day-to-day execution, have an understanding of what it would take for us to, and the different stages it would take for us to kind of go to production. It needs a lot of strong collaboration between the different teams to work together and kind of make this happen. So overdose of communication is always better in this case, because you're trying to kind of identify different aspects of risks across different areas here. So open plans, a lot of sharing, and having a cross-functional team with experience in this area can really, really set you apart right in the beginning itself. And we were very lucky to partner with Yum and their experienced team in this aspect. Moving on. I think high level, there were 3 different stages. I know we just have about 5 minutes and we have questions to cover as well, but we had 3 important stages. This is the actual practical implication of the initial process that I talked about. The first phase was running things manually. And even we actually sent out manual emails as well in this stage to actually test whether the model is working, the data is valid. So eliminate the modeling and the data risk in the first phase. The second phase was primarily about productionizing. Now we know what models are working. We know the results are there. So kind of setting up a strong environment for us to be able to push to production. And then the third aspect was the monitoring and operationalized layer on top of it. So once the production system is running, are we meeting the right SLAs? Is the data performance good? Is the data quality good throughout the overall system? So focusing a lot on those aspects in taking the third phase and stabilizing that. So operating in this layer-wise fashion eliminated risks at the right stages, and it allows you to redo the work, what is needed at that stage itself, rather than doing it after you've over-invested and built an entire ecosystem around it, and then you need to know that the modeling needs to change. Moving on. This is the technology stack that we took. I think it was very critical to divide the infrastructure into different areas. So what are we going to use for logging and monitoring? What are we going to use for reporting? So we tried to standardize the different technology stacks in different areas so that they can and integrate and kind of set them up together and also operationalize them with Terraform. So we basically try to create a go-to environment which is well integrated, has access to the different data sets that we have collected over periods of time, as well as has access to existing modeling technologies that we have created. So sort of have a go-to package which has a whole range of these technologies that the teams can start working on from the get-go. The exact technologies here were chosen after detailed technology evaluation around stability, use case, and future-proofness. It may vary depending on your cloud readiness and other things. So I won't call this as the Bible, but this was definitely the right stack for us from a Yum ecosystem perspective. And we were able to kind of reuse some of this again when we built new models and so on. So the idea was to basically build this up and set this up in the right way so that we can continue to use it all into the future. Moving on. I think move on. I'll talk about the next slide. So this was the flow that we used to actually productionize ML. So the final gist of the final production setup that we created. So all the different models that were created by the machine learning teams, we basically provided them platforms like Jupyter Notebooks to kind of write those things, and then submit them as modules to GitHub to kind of check them in. Then we had a CI system that used to pull in these models, Dockerize them, and set them up in the right way. Some machine learning teams may already be working on Dockerized containers. Some exchanges may just be at Python package level. Again, the exact process may vary depending on the maturity of the data sciences team and the technology stack that you want to use. The Dockerized containers were then submitted to Dockerized container registry, as well as they were integrated into workflow systems. So Airflow used to pull out from these Docker containers and push them into staging, prod, or other environments. These environments were basically composed of EKS systems and Airflow, which was pulling in these Docker containers, putting them into the workflow, and running them to finally produce customer data sets that could be pushed into Braze or the CRM systems that were being used. The intermediate data sets were all stored in S3. And we try to contain this entire thing into a standalone AWS account, which could be spawned off in order to manage governance and security aspects of it. I know we don't have time, so I can't go into a lot of detail here, but the core system here was created with that understanding in mind. So I know I talked about a lot of different things, and not everything is required in order to take any machine learning model to production. It's all depends on the obviously having more maturity in one of them than is needed is always good. But the idea is to understand how do you want to bring up the maturity of your different systems for your use case to make sure that you are kind of unblocking the teams and making them the most productive that is possible. Almost everyone would need a scalable environment. A lot of people would need some sort of model serving system, especially if they're serving out APIs, but you may be doing bulk processing, in which case you may not need a very sophisticated investment around that. Almost everyone should invest in detailed accessible statistics, servicing them up to business, and then finally having an experimentation framework is definitely depends on the use case, and not a lot of people invest in it right now, but we definitely see that as a must-have into the future. I think we're out of time, and we have a couple of questions, but yeah, go on.
Yeah. So in the interest of time, I know we're at the top hour now, and I apologize. I couldn't keep up with the time. But again, don't worry about it. I will make sure to answer all of your questions. I have basically noted all of those questions, so we will be sure to get back to you on this. But I just want to quickly take like 20 seconds to inform you all that we are about our next event, which is on July 30th. Now, this is going to be a very interesting one too, right? And I say that because, as you can see on the slide, we have such an interesting speakers from different industry background, sharing some, common challenges faced on how to go about getting a, tangible business outcome out of the investment you've made on the data analytics space, right? And I know that this is one of the biggest challenges, that analytics organizations are facing today. And I'm very excited about this event. You will get an email of this recorded session too, and also about our next event. And this will be on our website and LinkedIn. And if you face any issues looking at it, ping me directly, okay? So I think we're probably at the end of the session here. And I just want to thank everyone for joining, and you've been, wonderfully amazing audience today. And I hope you got some value out of this. And if there's anything we can do to help you, please do not hesitate to reach out. And, please take good care of yourself. This is Tenzin Namdak with the Sigmoid Group and the guest speaker, Scott Kasper, signing off. Thank you all.
Thanks, everyone.
Mm-hmm.